Multiplying by tens. First, we need to review that a product is the answer to a multiplication problem. Factors are the numbers being multiplied that go evenly into another number. So down here, these numbers are the factors, and these numbers are the products that you get when you multiply the numbers on the left. So look for the pattern in these products when 10 is one of the factors. What's happening? It looks like we're taking the first factor and just adding a 0 to the end. But why can we add the 0 to the end? When I have the number 7, it's represented by 7 counters in the ones column, and so that is the digit 7. If I multiply 7 times 10, that's taking each of those 7 counters and turning them into 10. I would have 10 sets of 7 or 7 sets of 10. I'd have to try to fit 70 counters in the ones column over here, because each of these would turn into 10. 10 times 7 would make 70. So the 7 counters are going to exchange. Every 10 counters are going to exchange for 1 10. So my 7 counters are really going to the left. So I've got 7 10s now instead of 7 1s, because it would be 70 ones exchanged for 7 10s. And now there's nothing in the ones column because there weren't any left over after I exchanged them all. If there's a decimal after the 7, then what really happened is the decimal went one place to the right. So to multiply by 10, you really move the decimal one place to the right. And if there's an empty spot, add a 0 if you need to. So the counters, or the digit 7, goes to the left, but the decimal goes to the right. So when we have 5 counters and we multiply 5 by 10, counters move to the left, and there's nothing in the right, and the decimal is after the 5, and so it moved to one place to the right. Nothing is there, so we've got to put a 0 in the ones column. So 5 times 10 is 50. In this table, we started off with the number 231, and when we multiply it by 10, the digits all go to the left, or the numbers representing the counters, and the decimal that was the end went to the right. Empty column, so a 0 had to be added in the empty column. Digits left, decimal right. So what will happen in 2,345 when we multiply it by 10? The digits will go to the left. And the decimal went to the right, which is creating an empty spot here to put in a 0. So 2,345 times 10 is 23,450. And in our last one, 4,108 times 10, digits go left, decimal goes right, putting a 0 in the last column. So 4,108 times 10 is 41,080. Pause the video while you work these 3 out. On the first one, if we move the decimal to the right one place, it allows us to add the 0. So 5,030. This one, number 2, if we move the decimal to the right one place, that makes us 6082 and an empty spot for a 0. So 60,820. And on number 3, if we go one place right with our decimal, then we get 60100, which is 60,100. So the rule is to multiply by 10, you move the decimal one place to the right. And if an empty spot is created, you add a 0 if needed. If there's already a number in that spot, you don't have to add a 0. But for now, we'll be adding zeros because we don't have digits after the decimal place. That will come later on in our decimals chapter. To stretch your thinking a little bit, pause the video and try filling in the missing factors on this screen. On the first one, 8 was multiplied by something to give 80, and there's a 0 on the end. That means it was multiplied by 10. So, because the decimal to go one place to the right to get that 0 in there needed to be multiplied by 10. The 220 has an extra 0 on than the 22 did, so it must have been multiplied by 10. The third one, we have 5,280 after it was multiplied by 10. So before it was multiplied by 10, it must have been short a 0. So 528 must have been what it started out as. And in the last one, after multiplying by 10, it ended up 74,600. So it has an extra 0 than it needed before it was multiplied by 10. So it was 7460 or 7,460 before it was multiplied by 10. To take 6 times 20, I'm going to break the 20 apart first. I'm going to make the 20 be 2 times 10. Because multiplication is associative, I can take 6 times 2 first and then take that answer times 10. So 6 times 2 is 12. 12 times 10 is 120. Let's try 27 times 30. I'm going to break the 30 into 3 times 10. So I'll have 27 times 3 times 10, but I'm going to do the 27 times 3 first. So if I multiply correctly, that gives me 800 or 81. So 81 times 10 gives me 810. Associative simply means that you can multiply sets of numbers in any order and get the same answer. So it doesn't matter if you take the 6 times the 2 before you take it times the 10. And you can break all numbers down into factors and multiply them in any order that you want. Pause the video while you try these. Okay, first you should have broken the 40 into 4 times 10. So you did 62 times 4 first, which gives you 248. So 248 times 10, because I have a 0, I go one place to the right, and that allows me to add the 0 on the end. So 2,480 was your first answer. In the second one, we'll make the 90 be 9 times 10. So we'll do the 1,970 times 9 first. 1,970 times 9. Again, if we get our facts right, we get 17,730. Multiplying that by 10, again, means I have to go one place to the right. So 17730 and another 0 for the 10 being multiplied on is 177,300.